All right, so here we go. We do have some learning to do today, so we've got to get through this. Number one, I think everybody in this room should have a good idea of how to start number one.
Okay, Brown got it.
But Bryce Akridge just showed up. What's the deal, Bryce?
No, Dan. Yeah, he got let out late.
Uh-huh.
Yeah.
All right, well, what about number one? Jabron, you have a thought. What's your thought?
What is the X to the fourth power?
No. Let's talk about this. When we change this to an exponent, this number's kind of on the bottom, right? It stays on the bottom. 4 to the x equals 16. 4 to the x equals 16. That's the way we write this. 4 to the x equals 16. Everybody got it? So what's the answer? 2. Easy. Everybody gets that one right. Now, look at the next one. Listen, I want to get through this, but I won't if you don't settle down. So let's pay attention. All right, take a look at this guy. We need to solve this. Taylor Holder, please focus. We need to solve this. Katie Buckgardner.
Oh, and some lead.
What's the key here? What are we going to need to do?
Change it to 3.
We're going to change everything to 3s. So instead of 9, we're going to have 3 squared. Right? Abby, you paying attention? And instead of 27, we're going to have 3 cubed. Now that they are both 3s, what are we allowed to do? Set the exponents equal. But when you do that, you guys, be careful. What's this exponent? 2x plus 2. And this one is 6x. Thomas Bird, did you follow that? We changed the 9 to 3 squared. And the 27 to 3 cubed. So now we can subtract 2x and divide by 4. I got 1/2 as my answer. Okay, what about you? You get 1/2?
Yeah.
Everybody okay with that question? Write as a single logarithm. That means log something. We're going to smush it all together. It's going to be a division, but there's something that has to happen first. This guy has to be taken care of first. And what will I do with him? No. Make him an exponent. Remember, kids, if you have a coefficient, it represents an exponent. If you have an exponent, you can make it a coefficient. This number can go back and forth. So we have log a cubed minus log b. Now I can put them together and they will go together as a division problem. So it will be a cubed divided by b. Why does it go together as a division? Because it's a subtraction problem. Yes, indeed. Now, the next one looks so complicated, but it's actually probably the easiest one on here. Tim?
LNE gets out.
Exactly, because LNE means log base E of E. This cancels, so the answer is just what? Root 2. Kids, ln e of anything is just going to be that every time. So ln e to the root 2 is just root 2. The answer is root 2. All right, now we got this giant exponent problem. Okay? All right, here we go. What are we going to do with this giant exponent problem? Square everything? We can start that way. When we square everything, it means everything. So we're going to have 4x to the what? 4th, y to the negative 6 over 9, x to the 20th, and y to the 10th. Remember, when you have a double exponent, like y to the 5th squared, you multiply them. So all of these exponents get times by 2. Okay? Now what? You got to take care of these guys. Now just think about it for a minute. You've got x's on the top and x's on the bottom. Who has the most? The bottom. How many more does the bottom have? 16. So you've got x to the 16th on the bottom. Now we got to take care of this. But wait a minute, wait a minute, wait a minute. That's negative. We don't do negative. So we're going to bring him down, right? We're going to bring 6 y's down. But there's already 10 of them down there. So now we're going to have 16 y's also. Madison, you doing okay this morning? Yep. All right. Okay. What do we do with this? So we'll rewrite it as 1 over. Remember, negative exponents mean 1 over. So 1 over 27 to the 2/3. What does the 2/3 mean? The cube root of 27 squared. Remember, fractional exponents mean radicals. So we have 1 over the cube root of 27 squared. What's the cube root of 27? 3 squared. Your answer is 1/9. Now this one is like the first one, kind of, the first question. You're going to rewrite this, and how will this get rewritten? 3 to the negative 2 equals x. What does 3 to the negative 2 mean? 1 over 3 squared. Oh my goodness, what's the answer to this question?
1/9.
1/9 again. Here's an easy one. Looks like a hard one, but it's super simple if you know your properties. What's the answer? 10. These cancel. The answer is just 10. That's a property. What's your quiz tomorrow going to look like?
This.
This. you're gonna have a problem like that tomorrow, don't waste time on it. The answer's 10. Now, this is the opposite of one we did earlier. Earlier, you were supposed to smush all the logs together. Now we're gonna pull it all apart. So you're gonna spread this out. You're gonna notice that you've got a multiplication and a division. So let's take care of this part right here. What are we gonna do here? If we pull this apart into two logarithms, what are we gonna have? The log of x plus the log of y. Why am I adding?
Because it's division.
Because that got multiplied right there, right? And then how am I gonna handle this? Minus the log of m. Think about it, if you squished all this back together, wouldn't you multiply these and divide that? We're just doing the opposite, we're pulling it apart. Number 10, we did a lot of this yesterday. I think you can handle this. Be careful. Do not drop the logs. You can't drop the logs till you do something else first. What do you have to do first? Gotta combine them. You can't have more than one logarithm on a side. So you gotta squish them together first. What will these become when they get squished together? 7x. These have got to be put together, okay? So here they are. Now, what can you do when you have a logarithm equal to a logarithm? You can set them equal. You can drop those out and say 7x equals 20. So x equals 27. 27. Now, dollars to donuts. Somebody tomorrow is going to write this. And it's going to be marked wrong. You can't drop the logarithms until you have 1 equal to 1. You see that? Can't have 2. So you got to squish first and then drop the logarithms. Okay? So what did I just say? Squish first and then drop the logarithms. Okay, let's look at number 11. We did a bunch of these a couple days ago. Step 1.
Divide by 5.
Divide by 5. And this is kind of like one we did earlier. What do we need to have happen? We need to have these guys match, don't we? So that's easy. 8 is 2 cubed. And now that they match, we can say x plus 1 equals 3. So the answer is 2. Step 1, divide. What's your thought on this one? Very good, Jabron. Jabron says, I got to deal with this first. Always got to deal with it. So that becomes an exponent, so this becomes the log base 2 of 27. How'd I get 27? 3 cubed minus the log base 2 of x equals 5. Okay, now what? Gotta squish. These are gonna get squished. So it's gonna be the log base 2 of what? 27 over x. Why is it 27 over x? Because it's a subtraction. Subtractions get squished as divisions.
So the answer's 5? Or the answer's that?
Well, I'm not done yet. This is where I am now. I gotta figure out what x equals. What do I do with this? You've done it 3 times already today. You're gonna rewrite it. How are you gonna rewrite it? How are you gonna rewrite this?
2 to the
There you go. 2 to the 5th equals 27 over x. 2 to the 5th equals 27 over x. Anytime you only have one logarithm, this is what you want to do. What's 2 to the 5th? 32. How do I solve that? Multiply by x, and then divide by 32. Okay, we went through the whole thing. I am willing to do a couple more practice problems. What kind do you feel like you're going to struggle with the most? What do you feel like you need an extra practice on? Which number, Katie?
You want like 12, please?
Like 12? Like the one we just did?
Yeah.
All right, Katie has asked, here is another example of a problem like number 12. All right, so how would we start this problem? Think about the last one we did. What did we take care of first, Katie?
Get rid of the 2.
Get rid of the 2. The 2 is going to become an exponent. So this is going to be the log base 4 of 25 because it's 5 squared. Now, you can't have 2 logarithms on the same side. You got to squish them. What are those going to squish together as? The log base 4 of what?
25.
25 times x. Now, what do you do when you only have one logarithm? Every time you only see one logarithm, what are you going to do?
4 to the 2.
4 to the 2 equals 25x. 4 to the 2nd equals 25x. What's 4 to the 2nd? So 16 equals 25x, and x equals 16 divided by 25.
Oh, yeah.
Anybody have another type of problem you'd like to do another practice on?
And I get that.
Last call. Any other kind of problem, one of these we need to do an extra practice one of. Okay, those of you who intend to study for this thing, I would suggest that maybe you recopy them on another piece of paper and try them again tonight and get ready for tomorrow. Tomorrow's quiz is going to have the same number of questions. I'll even put them in the same order. It'll just be different problems, okay? Yes.
Okay, so we'll have this quiz and then it says Friday. Is that like our last quiz? Is that our last 2 grades?
We may have another quiz sometime next week. Because we have one more thing to learn. That quiz covers the entire chapter except for the word problems. And that's what we're going to start today. Okay? So we'll probably have a little word problem quiz, 1 or 2 questions sometime next week, Monday or Tuesday or Wednesday, something like that. All right. Here's what I'd like you to do. Get your note sheets out and turn to page 30. We're getting out our note sheets. We're turning to page 30.
That's what I thought. The answer yesterday was like yes and no. Well,
And at the top of your note sheet, I need you to write these 2 formulas. Hey, right now, at the top of page 30, in that empty space up there, I want you to write these 2 formulas. You need to have these memorized by the time we take the test, which is a week. You may have seen these formulas before.
is that LT?
That's a 1.
Oh, 1.
That's a 1. That's a number 1. Plus. So A equals P times 1 plus R over N to the NT power. And this one we call the PERT formula. A equals PE to the RT, we call PERT. Now, we're going to do problems, and in the course of doing the problems, I'm going to help you understand what all those letters mean. So let's read question number 1. On page 30, our first word problem. How long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? All right, so here we go. $1,000 is the amount of money we're starting with, and that is always the p-value. The p-value is what you are starting with. The A value is what you are ending with. So in this problem, how much am I ending with? Double, which would be 2,000. Both formulas, the P is the starting amount and the A is the ending amount. That's consistent. P stands for principal, it's what you start with. A is the amount at the end.
So those are 2 different equations right there?
These are 2 different formulas.
And which one do we use?
We are using this one in this case.
But we can use either or.
No, you can't.
Okay.
This one is used for something else. The A and the P stand for the same thing, but for this problem, this is the formula we have to use, and I'll explain why as we go through.
Okay, that's cool.
So we have 2,000 equal to 1,000, 1 plus, okay, now R. Take a wild guess. What do you think the R stands for in this problem? The rate, which for us is what? 2.5%, but you can't put it in as 2.5, you have to put it in as 0.025. You're putting it in as its decimal.
Is that like supposed to be like an exponent? Why is that like cut above?
It's R over N.
Oh,
I'm plugging numbers into my formula. Now, the N is the number of times per year that you compound.
Quarterly, that would be 4 times.
4 times. So for this problem, N is 4. Notice that that N happens twice in the formula. It also shows up as an exponent. What do you think the T stands for? That's your time. This is your time in years. How many years?
Okay. Okay.
Now, Gibran asked a great question. He said, Mrs. Ford, you've given me 2 formulas. Can I use either one? Does it matter? And my answer to him was, yeah, it matters. And here's why. Do you see an N in this formula? No. If you are compounding quarterly, monthly, daily, if you are compounding a certain number of times per year, then you got to use the one we're using. It's the only one that has an N in it. Got it? So any problem that says compounded quarterly, compounded monthly, compounded daily, we're going to be using this formula. So here is the setup. Would everybody agree T is my variable, my unknown? Because it says how long will it take? Now you got to solve this, folks. You got to solve this.
Okay.
Okay. Any idea what step 1 might be?
Distribute that 4.
Can't do that.
Oh, distribute that 1,000.
Don't want to distribute it because this has an
Divide
extra.
the 1,000.
Divide by the 1,000. Good job. Divide by the 1,000. You want to get that 1,000 moved over. Now, let's see what's inside that parentheses. 1 plus 0.025 divided by 4. I'm going to rewrite this as 1.00625. See if you can get that too. Did you get that?
Yeah.
Yeah.
So that just looks a little better. It still looks bad, but it looks a little better than it did before.
Wait, so did you just divide 0.25 by 4, then add 1?
Mhm.
Okay.
Yep, and that's what I got.
Okay.
And that's just to kind of clean that up a little bit.
Okay.
What do I do now? I want, Bryce, you're right. I can't deal with this. I gotta have him out in front. But how do I get an exponent out in front? I can't just move it. What do I have to do first?
Multiply.
I have to take the logarithm of both sides. I need to take the logarithm of both sides. That is the only way to get that exponent down. So I'm going to have the log of 2 equal to the log of this number. And now I can pull the exponent out in front.
Okay. Okay, so we just throw a log in there. So do a little log action.
Have to do that. That is the only way to get this exponent down. Bryce said, I got to get that exponent down. He's right. But the only way to get it down is to have a logarithm. So I stuck a logarithm into the problem.
There's a log action going to solve this problem.
Now what's going to be the next step?
Throw some logs on
This is, you want to get this by itself.
Divide by 4.
So we could divide by 4. So we have the log of 2 divided by 4. I got some big long decimal. Okay, now what do you want to do? I want to get t by itself, so what am I going to have to do to get t by itself? divide by that. So I'm gonna take this big long decimal, that by the way is sitting on my calculator, so I'm not gonna round it off. I'm gonna use this number on my screen, and I'm gonna divide it by the log of 1.00625. So I'm just going to hit divided by log 1.00625. And I got about 27.8 years. Tell me if that's what you got.
Yeah. Long time.
Good job. You just did your first word problem. Good, good, good job. Okay, we're going to do another one. Let's read number 2. Have you read number 2? Okay, let's read it. And then tell me which formula we're going to need for problem number 2. The same one we used, right? How do I know I'm going to use the same formula over again? What are the words in the problem? Compounded monthly. When you see compounded monthly, quarterly, daily, when you see that, you know you are using this formula. So here we go. I'm using this formula. Who sees something to plug in somewhere? 1, 2, 3, 0. Tim, where's that going?
P.
That's P. Uh, 3.125%. Where's that going? R. But when I put it in, it's 0.03125. What does compounded monthly mean? 12 times a year, so N is 12 in this problem. At the end of 10 years, what do I do with the 10? That's T. What am I solving for? Does that make sense? What does A stand for? The ending amount? Is that what I'm looking for? How much will be in the account at the end? There we go. Now you're going to